a vector is, the definition of a vector is a quantity that has both a magnitude or a size, okay? Which magnitude and size are good, but we kind of refer to it more of distance, okay? Kind of like the length of it. And it also has a direction, okay? We're going to learn about direction later, but today we're going to talk about the magnitude a lot. We're really going to talk about that magnitude or the size of vectors. When looking at a vector, okay, so here's our vector here. Focus on point P. Okay, it has a solid point at it. That is your initial point. Then, as this vector goes, okay, it has an arrow at the other end where Q is at. That's called the terminal point. So where the regular point is at, that's your initial. Where the arrow is at, that's your terminal point. Another way to think about it is like when you were at home today, that's your initial point. When you came to school, that was your terminal point. Something happened in between, some type of transportation, okay? But you went from point A to point B. So that's kind of one way you can think of vectors. Any questions on initial versus terminal? Okay. Okay, and when we write vectors, so for example, if I say vector AB, you would write AB with a arrow above it. Okay, that's how we write a vector. You can also write it using the initial point. So maybe just P with an arrow. That means vector P. Okay, or a bold-faced P. So more times than not, it's going to be written the first way, where you have like vector PQ with the arrow above it. That's how we'll have that most often. Okay. Questions before we move on?
How did the test go? Did you get
I have not gotten my grades yet. I told myself that I was not. This is like very rare for me because I usually take everything home over breaks. I was like, I'm not doing it. Because it's 1 day tonight, 3 days off stuff. So sorry, but I will grade it today. Okay. All right. So magnitude. Okay. Magnitude is found using the distance formula. Do you remember the distance formula? Okay. It's where you take the x's, subtract it, squared, and then plus the y's. You've seen it before. Okay. Usually, when you see it, it looks like this. D equals, like distance equals. Okay. But the way that we write the magnitude is like this, with the double sticks on either side of the vector. See if I can make that a little bit bigger for you. Okay. So we're going to find the magnitude. And here's how we do it. We say the magnitude of AB. So double sticks and then our AB. The magnitude of AB is equal to, and we're going to do our square root, so we're using that formula. Okay, and I like to label my points. So I have x1 and y1 here, bless you, x2 and y2 here. I like to label them, that way I know exactly what's going into my formula. If you don't want to label, that's up to you. Okay, so if you look at our formula, it's x2 minus x1. Well, x2 is negative 7 minus x1, which is 8. Okay, don't forget the squares on those. We always have to put square. And then we do our y's. y2 is negative 2 minus y1, which is negative 4. Now, what do you notice at the end where it's negative 2 minus a negative 4? What can I do there? Yes, two negatives make a positive. So it's going to be negative 2 plus 4. Now, I'm going to stress that you don't just plug this in your calculator because something's going to go wrong. Okay? Here's how to go about doing it. Simplify it first. What's negative 7 minus 8? Negative 7 minus 8. Negative 15. Okay, negative 2 plus 4? 2. Okay, so that's how, so simplify it. Then, I'm going to pull up my calculator. And the biggest thing I can stress is use parentheses. Just get in the practice of doing that because your calculator does not know that when you square a negative, it becomes positive. So for example, if I was to write negative 15 squared plus 2 squared and type it exactly like that in my calculator, it's not going to give you the right answer. So here's what I'm saying about parentheses. Always just put parentheses around them, get used to doing it. That way you know you always have the right answer. Okay, so for my calculator here, I'm going to do negative 15 squared plus 2 squared. Okay, again, put it in parentheses, makes your life a lot easier. 229. Now, that's not the final answer because we still have our square root. Okay? If you were here on Tuesday, we broke down radicals. Now, I don't know if it really makes sense to break down radicals here because think about distance. If I asked you your distance from school to your house, you wouldn't tell me 2 radical 5 miles, right? You would just say 2 point whatever mile, or it wouldn't be 2 miles, but you would just say however many miles. If it was a decimal, it would be a decimal. So that's what we're going to do. So in your calculator, oops, that's not the one. You're going to press second x squared. That'll give you a square root, and then just do 229. So 15, we'll go to 2 decimal places. We'll just make that a rule right now. Go to 2 decimal places, 15.13. Now, we don't know what kind of units this is. We don't have a word problem here. So basically what you just found is if we were to draw vector AB, it would be 15.13 units. Maybe that's feet, maybe that's miles, meters, I don't know what it is. Okay, but we'll just put units there for now. Okay. So this is the length or magnitude or size of that. Questions for me on that? Okay, let's do RS. Okay, if it helps you to label, go ahead and label. So we should get, for our x's, 5 plus 3, because it would be 5 minus the negative. And then 6 minus 10. Okay, what's 5 plus 3? 8. And what's 6 minus 10? Negative 4. Okay, now we can put our 8 squared plus negative 4 squared in our calculator. Oh, well, technically I should have had a negative in here. It's not going to make much of a difference, but that's okay. Okay, 80. Should get 80. Anybody not get 80 on that one? Okay, so again, that's still under a square root. We didn't put it in the square root yet. Then we can go back, put that in a square root. Okay, now I do it by steps like that just because I've seen people put in this under a square root and things just get weird. Okay, so that's why I do it step by step. All right, so 8.94. Okay, go ahead and do the next 2 by yourself. Okay, same exact process. Go ahead and do the next 2 by yourself. I will put them up here on the board. Keep in mind the rule of rounding, okay? If it is 5 or greater, you round up. So for example, square root of 29 is 5.385. Okay, so since it's 5, I've rounded up to 39 on that one. Okay, maybe not getting these answers, maybe confused, have questions on using the distance formula for magnitude. Okay, give me a couple more seconds here, and then we'll keep moving. All right, zero vector, okay? A zero vector is basically nothing, okay? That's kind of a weird way of saying it, but if it doesn't have a magnitude, okay, we can't see it. So think about, like, distance, okay? If you have a zero distance, you don't go anywhere. Okay, size 0 is just 0. You go anywhere. Will you see it very often? No. Okay, I need you to know what it is, just in case. All right, our other types of vectors. Parallel vectors. You can probably guess what those are going to look like. We have equivalent vectors and opposite vectors. So, if we're looking at parallel vectors, okay, here's an example of parallel vectors. Not necessarily the same size, okay, but they are going the same direction. Oh, I guess they don't have to be going the same direction. Well, that would be opposite. No, it wouldn't. Sorry, they can be going different directions. Okay, but they don't have to be the same size if they're parallel. Okay. Now, does anybody remember if two lines are parallel? No, we're not talking lines here. We're talking vectors. But still, if two lines are parallel, what do we know about their slopes? They're going to be the same. Okay. The slopes are the exact same as something that's parallel. We're going to come back to that. Okay. Next is equivalent. Equivalent. Okay. What's another word for equivalent? Equal. Okay. Which is kind of an equivalent in a way. Okay. Equal means the same, the exact same. So when you have equivalent vectors, they are exact same size, exact same direction. Okay. There's nothing different about equivalent vectors. Opposite vectors. Okay. They have the same magnitude. They're the same size. Okay. Same size. They're just going opposite directions. Same size, they're just going opposite directions. Okay, we're going to pick out some different ones here. So I'm going to go ahead and highlight for you just in case you can't see them. A and E. So here's A, here's E. Okay, first, look and see if you can find the arrow on those. You may have to look on your paper. Okay, that's going to help tell you something. Okay, what are you thinking? Okay, opposite. Why are they not equivalent? They're not facing the same direction. Equivalence is exactly the same. Gentlemen, please stop talking. Okay, so if they're going opposite directions, but they look the same, that's going to be opposite vectors. Okay, what about I and F? Let me highlight those. Here's F and here's I. What do you think? Okay, it's either parallel, equivalent, opposite, or none. What do you think, Emmett? Okay, Emmett thinks equivalent. Okay, now for them to be equivalent, they have to go in the same direction. Are they going in the same direction? Yes. Okay, do they look about the same size? Yeah. Okay, we'll call them equivalent. Okay, now keep in mind, we are ballparking this. Okay, we're not 100% sure that they're exactly equivalent, but they look pretty darn close. We're going to talk about equivalence here in a little bit. Okay, next is D and E. D. Ooh, what do you think about D and E? What do you think? Are they equivalent? They are parallel. They're going the same direction. Okay, they don't have to be going the same direction, but they are. Okay, now if we want to prove these parallel, what would we have to do? We just talked about it. I think Warren got it right. If two lines are parallel, their slopes are equal, so we have to find the slope. Okay, now we're not going to do that right now. We're going to do that here in a little bit. All right, B and G. Go Falcons. Anybody get that? Anybody? Anybody left? Yep. Okay, what do you think? None. Okay. Something weird's happening. Okay, those are not related. Okay, and then C and H. There's C, there's H. What do you think about C and H? Okay, now equivalent is close, but why are they not equivalent? They're facing opposite directions. This arrow is right here, this arrow is right there. What are they? They are opposite. Okay, questions for me on types of vectors? Okay, let's talk equivalence. Okay, here's how we show that two vectors are equivalent. Okay, they have to have the same magnitude. So we're going to do the distance formula, which is what we just did on the first page. The second thing, okay, they have to be going the same direction. We're going to use slope formula. Does anybody remember slope formula? M equals y2 minus y1 over x2 minus x1. That's how you find the slope of a line. Okay. So we're going to go ahead and do our distance formula first. Okay, so we're going to find our magnitude first. If you want to label, you can label. If you don't like to label, that's fine. Okay, so distance formula first. -2 plus 6. All right, so I would have, bless you. Should be 1/16. Technically, you don't have to find the decimal here, but that's fine. Okay, so that's AB. Have to do CD. Okay, I'm getting the same magnitude. Okay? Questions on getting that magnitude? Any issues? Okay, that's step one. Okay, step two is that slope formula. So we're going to find the slope, which we note as m. Okay, we're going to find the slope of AB. Okay, now you're going to use your x1, y1, all of that. Okay, here's our slope formula. Y2 minus y1. Y is always on top. So we do 3 minus the negative 7. That'll become plus. Double negatives make a positive. And then our y's, x's, negative 2 minus a negative 6. Again, that'll be plus. So here we get 10 over 4. Do you need to reduce it? Not for this purpose. Okay, you could if you wanted to. All right, then we find the slope of CD. So do our y's on top, 0 minus a negative 10. That become positive. And then our x is 6 minus 2. So it'd be 10 over 4. Okay, do they have the same magnitude? Yes. Do they have the same slopes? Yes. Okay, that means they are equivalent. Okay, so number 10 is equivalent. Okay, now number 11, you're going to do the exact same process. I want you to at least do the magnitude. So go ahead and do the magnitude for number 11. Okay, if you can do the slope, go for it. Okay, I know it's just been a while since you all have done the slope. Okay, so go ahead and do the magnitude at least, and then we'll come back together here in a second and we'll do the slope. Okay, did y'all get the same magnitude? Did we get the same magnitude? Yes, hopefully. Okay, hopefully you're getting square root of 160 for both of them. Okay, then you have to do the slope. Okay, I'm going to walk through slope with you in case you need to see it again. Okay, so for my slope, I'm going to do y's on top. So here for my AB, I'm going to do negative 14 minus a negative 2. Okay, when I do minus a negative 2, that becomes positive. Okay, and then my x is on the bottom, 6 minus 2. So here I get negative 12 over 4, which is negative 3. Now, if my slope for CD is negative 3, then I'm good to go. Let's see what happens. So again, my y is on top, 4 minus negative 8. Okay, it's like 4 plus 8. X is on the bottom. 1 minus negative 3 becomes positive. So I get 12 over 4, which is positive 3. So since one slope was negative, you gotta hear this, guys. Since one slope was negative and one slope was positive, these are not equivalent, okay? Everything has to be the same. Okay, so this one's no. Now, let's take it one step further. Thinking about the types, okay, so we have opposite, parallel, and equivalent. If we're looking at opposite slopes, okay, what kind of vectors do we have? Opposite vectors. Okay? Because they're the same size, but they're pointing a different direction. Okay, they're pointing opposite direction. So in this case, it would have been opposite vector. Okay, now we're going to stop there. We'll continue these notes later. Okay, so this is just this part. But go ahead and flip a couple pages. Okay, so it says homework on it. Okay, just classwork. So flip to the homework section. You're just going to do the first page. Okay, everything else will be what we're going to do later. So it's just that front page. Okay, is the practice. Right. I will leave my answer key up here if you want to check your answers.